This is Dr. Dan Lieberman, and I'm here to talk to you today about another new development. Elon Musk's latest attempt to disrupt yet another industry, your brain. Let's get into it. Brain-machine interface is not a new problem. People have been working on this for decades. Actually, DARPA, the people who brought you the internet, were one of the original funders of technology to create an interface between the human brain and an electronic machine. Well, why would anyone want to do that? Well, there's a lot of really legit reasons. To begin with, you could control things. You might be able to control systems that require so much speed, even a human hand is not fast enough. Military pilots, for example, if you could move things with your eyes, there's a lot of control issues, and we're going to talk more about those applications. And then there's a whole second array, and that is replacing sensory input into people who've been injured. What if we could take the vision of the world, digitize it, and put those signals into the brain of a person who was blind? It would be literally bringing sight to the blind, hearing to the deaf. So there's a lot of really legit reasons, and spinal cord injury is a third enormous area here. When someone becomes paralyzed, what if Luke Skywalker's hand was real? If there was something that could control a prosthesis without having all the awkward robotics of external fixation and what have you. They're motivated to do it. There's a lot of great things that it could be done, but is it really possible? It is. So in order to really understand what Neuralink is, we have to kind of back up and talk first about how the brain controls stuff. Let's say I want to pick up my coffee cup. So I can see the cup and I pick it up. No, that's not how that happened. So the way that that actually happened was my brain had the desire, the idea that I was going to pick up the cup, and then my motor cortex made a little minuscule movement, and then proprioception, the sixth sense, brought that message of where I moved back to my brain. My brain then created a corrective signal to take the next little toward the coffee cup, and that went on hundreds of thousands of times. What looks like smooth movement to you isn't smooth at all. It's iterative corrections done over and over and over by the brain. So that's the way the brain works. The brain is in a really fast feedback loop where if we're talking about movement, what moved, where it moved, and then correction, correction, correction. The interesting thing about the brain is it's inside it's behind your eyes and above your ears. It's in a dark protective area. Your brain doesn't really know what it's controlling. It knows what the input is and it knows what the output is, but the brain controlling movement is no different from the brain's point of view than the brain controlling the cursor on a video game. So if you give the brain an input and an output, the brain can act as that iterative control. Well, Neuralink is the input. Neuralink takes the signal from the brain and connects it to something, and then the brain can act again and act in a coordinated fashion. How? Well, because the brain is an electrical organ. You know that symbol you see all the time of somebody having an idea and there being a light bulb above their head? Well, in a way, it's kind of true-ish. Your brain is an electrical organ. The electricity in the brain is about half a watt, so don't get too impressed with yourself. You're not even a 20-watt bulb. You're about half a watt, but you've got electricity. Well, if you sensed the electricity over a tiny part of the brain, and then you allowed the brain a feedback loop, you could create a control system. And that's a brain-machine interface. I mean, what? Is this really, has it ever been done? Actually, it has been done and studied quite a bit. The original brain-machine interface studies sponsored by DARPA were all about developing electronics that wouldn't break when the brain pulsates. You know, if you tried to rip a paperclip in half, you could never do it. But if you bend the paperclip like this over and over and over, you can easily do it. Well, it's the same thing with your brain. If there's an electrical wire that's connected to the brain and the brain is pulsating, it's going to break that wire. So there's been a lot of work done to create the interface, and most of those problems have now reached the point where they've largely been solved. With more remote sensors that don't have to touch the brain or can be slightly above it, and using computers to control for the changes in this signal, they've actually gotten to the point where they can use real brains as a loop. Animal studies are an important part of scientific development, and one of the first animal studies that was done for brain-machine interface was using a monkey and implanting a brain-machine interface and then seeing if the monkey could control a robotic arm. And sure enough, even a 3-joint robotic arm can be controlled remotely by a monkey so that the monkey can feed himself just by thinking about it. How? Well, the monkey doesn't understand the robotics. The monkey's hungry. And its brain can, with that motivation, that brain and the right feedback loop just learns how to control it, iteratively training one time after another until it can actually do it. Pretty cool, right? That a monkey could feed himself with a robotic arm just by thinking about it. Another one is the classic rat in a maze. In experiments in this area, rats implanted with a brain-machine interface can pilot a remote control car, and the rat can think its way to drive the RC car through a maze. Yeah, that's happened for a long time now. So we've got a platform of experimental animals that have proven these concepts. The first people to try it on would be people who don't have any other choice. People who are handicapped. Imagine if you were paralyzed and you got in an elevator and you could push the button or activate the elevator by thinking of the floor you want to go to. That would change your life in a very, very positive and profound way. So there's a lot of really cool things that are happening in the control universe. And don't forget about the replacing missing sensory input universe. The National Institutes of Health has studied electrical systems to replace vision for decades, and there's actually been some progress. Now, it's not, allowing the blind to see, which is, of course, what everyone would want, but it is creating visual images in the brain of a blind person to allow them to interact with the world more fully, which is ultimately the true promise of all technology, brain-machine interface or other, right? We're just trying to use these tools to interact more fully with the world around us. So you've got the brain that's half a watt, and you've got these signals, electrical signals, going through the brain, and you want to record those signals. You know what would make it really hard to record those really faint signals? A big, thick bone right in your way. And that bone is known to us as your skull. So the hardest thing about brain-machine interface, Neuralink or any other BMI, is trying to get good recordings that are not recording through the skull. So Neuralink and other companies will have to decide whether they want the skull removed in order to get to better recordings. And neurologists have been recording EEG off the surface of the brain for generations. If you want to get really good recordings, we make a burr hole. A neurosurgeon will take a small drill off the skull, and implant the sensor either on the dura, which is kind of a leather-like lining of the brain, or even on the brain itself. Remember, if you get on the brain itself, you get into the pulsation issue. These are the engineering challenges that Neuralink and, I'm sure we'll see other competitors, has to address and solve. And whoever solves them the safest, the first, is going to really open up an entire new avenue for technology to make us live better and fuller lives. So what is Neuralink? Neuralink is Elon Musk's brain-machine interface. Is it possible? Definitely. Yeah, the Tesla truck may have been delayed, but there is a Tesla truck. That's what I want to tell you today. There is a device here which can lead to and impact all of our lives. Where is this all going and when are we going to get there? We're going to have to wait and see. But I, for one, am excited. It's going to be reasonably safe. If you need it, the risk of it is going to be a tiny fraction compared to the benefit. And it's just another avenue or another step in progress for us to live better, fuller lives with technology. Thanks for tuning in.